All right. So again, today we're doing factoring by grouping. And whenever we do factoring by grouping, it's really still just doing GCF. The only difference is we're going to be given a lot of different terms in our original polynomial. Normally, anytime you're asked to do factoring by grouping, you're going to start off having 4 terms. So, in order to factor by grouping, you're going to split those 4 terms into 2 separate binomials and then take out a GCF. So again, factoring by grouping, you split the polynomial into groups and factor out GCF. That's why it's called factoring by grouping. So split the polynomial into groups and factor out the GCF. Yeah, that's what we're going to be doing anytime we're talking about factoring by grouping. We're going to split it, and then we're still doing GCFs. So we're going to do an example, and I'm going to write some notes with this example as well so that you have something to refer back to. So actual steps. So now, the first example we're going to have is going to be 24 n to the third plus 9 n to the second minus 64 n minus 24. So now we have 4 terms. There is not a common factor that goes into all 4 of those terms. You still always want to check for ECF because you could have one at the beginning. So you should always check for a GCF. So I'm actually going to put it as my first step. Check for GCF and factor out if there is one. Now, on this one, is there a GCF? No. All right, so for the first example, there's no GCF. But, again, we will have a few on this paper that do have GCFs. So now, the next step, we're actually going to split it. So we're getting into the factoring by grouping. Now, I've done this many different ways throughout the years. Sometimes I've used parentheses. Sometimes I show it using our box method. But over the years, I think the simplest, easiest way to do this is just to actually draw a line. We're going to split this right down the middle. So there's 2 terms to the one side, 2 terms to the other side. So we're splitting this into 2 separate things. So we split the 4 terms into 2 binomials. Split the 4 terms into 2 binomials. Now, a lot of teachers will also say, hey, sometimes you might want to rearrange these so that you have more like terms in one set and more like terms in the other set. You don't really have to rearrange anything. You can just leave it how it is, draw your line down the middle, it's separated into 2 separate binomials, and now we're going to take a look at those 2 binomials separately and factor out a GCF from each binomial. So that's going to be our next step. Factor out GCF from each binomial. So on that first one, what can come out of both 24 and 9? So what number comes out of both of those? Three. Yeah, 3 comes out of both of those values. All right. And then also looking at the n's, we have an n on each of these. So we can take out an n to what power can come out of both of those? So we have an n to the third and n to the second. So n to the second is our smaller of the 2 values, right? So that's what we can take out from both of those. Now, once we take that out, we also have to put what's left over. Because again, when we say factor out, we got to put the leftover factor next to it. So divide this factor off. So 24 divided by 3 is 8. If you divide off two of these n values, you're only left with 1n. Divide 9 by 3, that gives us 3. Divide off those two n's, there's no n's left, so that's it. So we have 8n plus 3 left in parentheses. Now, for the second term, well, the first value is a negative, so we're going to factor out a negative as well. Now, I'm always going to put the sign here no matter what, because mathematically, if I didn't show this green cross here that I put here, mathematically, at this point, you would end up with some type of sign in between these two values. So we're going to factor something out. Whether it's a positive number or a negative number, I'm going to put the sign here every single time. This time, since we had a negative to start, it's a negative that's coming out. 64 and 24. What's a common factor with both of those? So common factor with 64 and 24 would be, well, 8. 12 doesn't work, 8 does. All right. Now, what's going to happen once you take out this common factor? What's left over when we factor it out? So divide this by negative 8, we get positive 8n. Divide this by negative 8, we get positive 3. Notice, this parenthesis we just wrote is the same exact thing as the parenthesis over here. At this point, the two parentheses should be exactly the same. If you're told to do factoring by grouping, and you come to this step and they're not the same, something's wrong. Go back, check your work. All right. Now, on here, the fact that these two parentheses should end up being the same, that can also help you figure out your GCF for this second set. Because if I know that in the parentheses I'm going to have to get 8, well then, take 64, divide by that number, and I should know what GCF is going to come out. Or I could do the same thing with 24. I know that 24 would end up having to be 3, so 24 divided by 3 would also give me 8. So again, that tells you what's going to come out. So you can use that knowledge that you know where you have to go with it, you know what has to be your set of parentheses to help you figure out that common factor. All right, now that we have a common factor, we are going to actually factor that piece out as our new GCF, because these two numbers are being multiplied, right? This number and this binomial is being multiplied. This number and this binomial are being multiplied. So this entire binomial is actually now considered a GCF. It's a common factor on both sides of the equation. So we are going to factor out the common binomial as GCF. So we're taking this, we're bringing it out to the front. So I have 8n plus 3 comes out. The other two values would then come together. So we'd have 3n squared minus 8. And that's going to give us our other binomial. So we're going to combine the two leftover terms as the second factor. Move that up just a little bit. Now, what I want you to understand here is what we just did is no different than taking out GCF any other time. So, let me go back for a second to this last step.
Hold on. I need to know that one.
Okay. Yeah, I'm all right underneath. So, essentially, if you thought of this as we had 3n squared, and then instead of having this 8n plus 3, let's just call that x. We're going to use x to represent that entire binomial. And then over here, I had negative 8. Again, that whole thing, since it's the same, it just represented as x. Well, if we were factoring out a GCF, what do? We take out the common factor out in front, And then what's left over, all right, we divide it off, and what's left over goes in parentheses next to it. That's all we did here. From there to there, we did the same idea. It's just that x is actually an entire binomial. But it's the same concept as what we just did. All right? Whoops. Apparently that sticky note is better than I thought it was. Let's rip my paper. Hold on. Let me grab a piece of tape for that. Never had a sticky note rip my paper. There we go. Can't even tell it's written now. All right. So now we're going to look at a couple other examples. So I'm going to write out 3 different examples here. And we're going to do these 3 examples together. And then I'll have a couple for you to try on your own in just a minute as well. Yeah, so this was p cubed, so to the third power, plus 2p squared, plus 6p plus 12. And on this next one we have 8k cubed minus 14k squared plus 4k minus 7. And then for the last one here, 10n to the 4th minus 6n cubed minus 60n squared plus 36n. Yeah, passes up down the wall. So, all right. So I'm going to give you guys a second to get those copied down. Again, we'll do these ones together. So just get them copied, and we'll do them together here in just a moment. Well, again, all these ones that we do factoring by grouping, they're all going to be 4 terms. All right. So they are going to be kind of long. No, next Monday we're off. Yeah, next Monday. I think next Monday's for Strawberry Festival. That's in Plant City. Yeah.
You going?
It's not bad if you take the back roads from here.
Oh yeah.
If you go out like 674 or 672, either one of those, out to 39 and take 39 all the way up to Plant City, it's not that bad. It's about, I think it's about a 40-minute drive from here if you do that.
Is there only one way to get to Clearwater?
I mean, to get to Clearwater, you either go north through Tampa or you could go south through St. Pete and go up. But it's...
Tampa is faster though.
Yeah, Tampa's going to be faster for Clearwater, probably. It also depends on traffic, though. All right. So, hopefully you guys got those copied. Now, number 2. So, this one, we're splitting, again, just like we did on the other one. There is no common factor for all 4 terms. So, again, we go straight to factoring by grouping. Now, what can we take out of the first 2? Well, p squared. Yeah, there's no numerical value this time, but we can still take out a p squared. What's left over? P plus 2, yeah. So now, again, we have that as a reference. We could look back at that and be like, hey, I know over here our parentheses should end up being P plus 2. So if I divide this one by P, that gives me 6, right? Is 6 a common factor for both of those?
Yes.
Yeah. So again, we can use that to help out. So we're taking out a positive 6. Like I said on the last one, I'm always going to put my sign here because if I didn't put that little green cross to show how I'm splitting this, I want this to be mathematically correct. So again, I'm going to have my plus sign there. And then what's left over? P plus 2. Well, that P plus 2 is the same on both parts. So bring that out to the front. And the 2 that are left over, we got P squared plus 6. And that's it. On number 3. Again, is there a GCF here? You see a GCF? I don't see a GCF.
2. Oh, never mind.
No, I got 7 down there. Again, in order for it to be a GCF, it'd have to work in every single one of those, right? So 2 doesn't work in 7. So we don't have a GCF other than 1. So we're not going to take anything out there. So we're going to split this again. In the first set, there is a common GCF of 2 in those two, so we can go ahead and take out the 2 this time. The K values, we have a K to the second. What's left over? 4K minus 7. Do these have anything in common? Do those two have anything in common? No. Nothing but 1. So, again, like I said last week, when we have a lot of our different types of factoring, you're going to have to take out the GCF of 1 in factoring by grouping. So on here, we have to show we're taking out the GCF of 1. Even though that's the only common factor there, and it doesn't seem like it'd be important, you still have to take it out. So here, we took out a positive 1. We're left with 4K minus 7. And again, we have to take out that positive 1 because otherwise we wouldn't be actually multiplying over here, and this wouldn't be a factor. We need this to be a GCF. So we need these two to be the same, and we need them to be multiplied with another number. So we had to take out that common factor as 1. Once you take out that common factor, again, we have 4K minus 7 coming out in front. And we have the other 2 coming together as 2K squared plus 1. And we're done. So again, those are our final answers. Now, on number 4, is there a GCF? Is there a GCF?
Yeah, 1.
Bigger than 1 this time. 2, we can take out of every single one of those numbers. Is there anything else we can take out of every single number? We can take out an n from every single value. So we can take out a 2 and an n. Again, if there is a GCF, we want to take it out at the beginning. Because if you wait till the end, you're going to forget about it. And again, most of the time the directions are going to be factored completely. And you have to take it out as a separate factor. All right. So here we have that 2n. Now, what's left over? This is just like last week. Factor it out by dividing it off of every single one of those values. So we're dividing every value by 2n. So this becomes 5n to the third minus 3n squared minus 30n plus 18. Now, for the next step, we don't need this 2 for the next step, this 2n. So I'm going to drop it down past the next step because we still need it as a common factor in the end. But for the next step, we're doing the factoring by grouping, we don't need it. So drop it on down. Again, we'll need it at the end. So now, just like we were doing before, we have factoring by grouping. We split them. The first set, 5 and 3, they don't have a common factor, but we do have n's. So we can take out an n to the second power here. What's left over? 5n minus 3. In this set, we got a negative out in front, so I'm going to take that out as well. We have a 30 and an 18. They have a common factor of, well, 2 works. It's common, but it's not the greatest. We want the greatest. 6 is the greatest, yeah. So 6. What's left over? 5n minus 3. So now, that 5n minus 3 is the same common factor in both. So it comes out. And then the n to the second minus 6 come together as the other. Now, for your final answers, does it matter what order you write your factors in? So, does it matter? I have 3 different factors here, right?
Why you took out n2 and on square?
Again, that was what was left over in front, right? So, at this point, again, these 2 were the same, so they came together as one. These 2 that were left over came together as the second one. Again, once you have these factors, it doesn't matter what order you write them in, because when we're multiplying, again, order doesn't matter when you're just multiplying, right? So, on here, I could reverse the order of these. Same thing up here. Could have reversed the order of those. Could have reversed the order of those. And it'd still be the same answer. So if you're looking at questions like this on like a multiple choice test, again, the order in which you have these factors doesn't matter. The reason I write the order the way I do is because I'm following the steps of factoring, following steps of actually taking out a GCF. But again, the actual order that you write them in the end doesn't matter. So now I'm going to give you a couple to try. So try these 2 here. One of them won't have a GCF, one of them will. So just be careful of the GCF. But we have 7n to the third minus 35n to the second plus 2n. Yes, sorry. Minus 10. So again, that's 7n to the third minus 35n to the second plus 2n minus 10. For number 6, the other one that I want you to try, we're going to have 10x to the fourth plus 40x to the third plus 6x to the second plus 24x. So again, those are the 2 I want you to try. So take a moment, try them on your own, and then I'll show you the answers. Again, one of them has a GCF, one of them doesn't. So if it doesn't have a GCF, then you go straight to factor by grouping. Split them up into 2 binomials, take out your GCFs, and go from there. All right. Let's talk through this real quick. And this will be the last thing for our notes for today. So, on number 5 there, again, that one does not have a GCF. So on number 5, no GCF. I started by doing the little cross there to separate my two terms. So I have my two binomials. I took out the GCF from the first set as 7n squared. I took the GCF out of the second one as 2. In the parentheses, then, what was left over in both cases was n minus 5. That n minus 5, since it was the same, came out together as our new GCF. The other two came together as our other factor. Number 6, same thing, except this time, all those do share a common factor. So there is a GCF this time. GCF on those is 2x. So we're able to take out the 2x first, which leaves us with these values here. Then, from the first two, we can take out a 5x squared. From the second two, we can take out a 3. The leftover in the parentheses is x plus 4 both times. So x plus 4 comes together as one set of parentheses. The 5x squared and the 3 come together as the other set. Again, the 2x from the very beginning also drops down and is part of our final answer. But again, this is factoring by grouping. Now, factoring by grouping is something that will work pretty much every single time. So we have to do GCF, all right? And then the other type of factoring that we're going to talk about this week is factoring trinomials. But when we factor trinomials, we are still doing GCFs, and we're also still doing factoring by grouping. So again, everything else builds off of this concept of factoring by grouping. So if you can get this down, then it makes the other stuff a lot easier. All right. Any other questions on this? All right.